Well, good morning, mathletes. Here we go. Are you ready? It's Thursday morning, bright and early, and we're going to get her done today. Okay. This is probably the most difficult section to teach. What intuitively seems very easy, visually can be very difficult. This is harder to me than anything. It took me a long time to be able to see it myself. So stick with me. I know I'm making you take 2 sets of notes, one for Math Nation and my own, but you're going to need the practice. Just like with volume, we did easier problems first, and then we moved on to more difficult problems yesterday. Today we're going to start off a little bit on the slower side, just taking notes, and then tomorrow the problems get much more difficult. Okay, so let's jump in. Alrighty, and I lost my pencil. So we're talking about surface area. Just like in volume, we're going to start with prisms and cylinders. But surface area, the surface, and there goes the pencil. The part you can touch. The part you can touch, the surface, the top, the bottom, which we usually call our bases, and then the sides, which we're going to call lateral area. We already know the bases was called base area. And now we're going to use the word lateral. I've been working with you guys all school year to get lateral, like a lateral throw, lateral to the side. We're going to do everything we can touch. Can I touch the top? Can I touch the bottom? Can I touch the sides? So we're going to talk about surface area. Surface area is area which is two-dimensional. So let's stick over here, two-dimensional. Two-dimensional, all right? We know what a prism is, so I'm not going to read that. The lateral faces are the remaining faces, not the bases, but the faces. And that is huge. The side faces. So when I talk about lateral area, I am not talking about the base. I'm talking about the lateral area. And in a prism, those lateral area are rectangles. So lateral, the bases would be the top and the bottom. Remember, we named a shape by their base. In this particular case, this is a pentagon. So this would be a pentagonal pyramid. All right, again over here, the bases are what kind of shape? Right, triangular. And the sides, the lateral area, are rectangles. Those are the sides. This side and this side. And the side that we're really not able to color in, the front side, is all the way across. Okay, so seeing these shapes is the most difficult part. Bases and sides, lateral. Okay, an altitude of a prism is perpendicular segment that joins the planes. I kept saying that we needed to be perpendicular to the base. That is your altitude. That's perpendicular height. To be perpendicular to the base would be this height. It's perpendicular to the base. We could also find this perpendicular height through the center. It does not only have to be along an edge, but it can be from the middle to the middle, and then we could draw the height coming through the middle. But it's still going to be perpendicular. The lateral area, which we're going to call LA, the lateral area, and don't forget lateral means the sides of a prism, is the sum of the areas of the lateral faces. So it's this rectangle plus this rectangle plus the rectangle in the back, okay? It'll have altogether 5 sides. It's the sum of those sides. The surface area is the sum of the lateral area and the area of the 2 bases. So when we put it all together, we're going to have 2 parts. We're always going to be talking about the lateral area, which is the sides, plus the big B, which is the base area. And because this is a lateral area and this is a lateral area, area is 2-dimensional, sides area is 2-dimensional. 2-dimensional plus 2-dimensional gives me 2-dimensional, which is my entire surface area. So these are 2D, not 3D. Notice that we're adding, not multiplying. Okay? It's in 2 parts. If I want the entire shape, we add those 2 parts. If we want just the sides, that would be the lateral area. If we want just the bases, that would be the base area. So lateral area plus the base area. Okay. Why am I making such a big deal about this? Because in these shapes, these are real life examples. Maybe I need to do a roof. Well, I'd only do the surface area of the first base because the roof would be on the top. Let's pretend this is a flat roof. Maybe I'm painting my house. Well, not only am I going to worry about not painting the roof, I would not be able to paint the bottom of the house because that bottom of the house is on the ground. So when you basically paint a house, you're painting the lateral area or the sides and maybe around the top of the roof, which we might want to call that the fascia of the roof, and the concrete building minus a window or 2. But that could very easily be a house. And we have to put these into perspective. We don't always want both bases and the sides. Sometimes we want just the roof. Sometimes we want to paint just the outside of the house. We can never paint the bottom because it's on the ground. So when we read these problems, are they asking me to paint a cup, which I just want to stripe like a label around it? So how big would this be? How large would this area be minus the bases? I just want the sides. And this would be an example. Man, this cost me $100 on the black market toilet paper tube. Just kidding. This is a perfect example where we only need the area of the sides because there is no what? There is no bases. Okay? And how would we find the area of the sides? And that's what we're going to talk about today. All right? Okay. So when we have a shape like a prism, we have two bases. Now we already know how to find the area of the base. The area of the base is length times width, and I'm doing bases in pink, so length times width would give me the area of the base. The area of the base, that's these two pieces. Then we'd have to do the area of the four rectangles, because we have 1, 2, 3, 4 when we open this up. So why do we say the sum? Why do we say the sum of the bases and the sum of the sides? Because we're going to put the base areas together, and in this case, how many bases do we have? We have 2 big B, we have 2 big base area, and we have 4 rectangles, which is my lateral area. And all together we end up with the area of the whole thing. But in math, there's sometimes an easier way to do it. And if you notice, when we open up this prism, this length and this width of the base actually adjoins and attaches. So let's look at this shape. Okay, here is my prism. This is a crystal light container, by the way, so they're everywhere. This base and this base would be my 2 bases, and then the sides would literally open up like 4 rectangles. Notice this flat side of this lateral I ended up cutting, so this technically is one side. There's one side, 2 sides, 3, okay, 4. 1, 2, 3, and 4. That is 4 lateral rectangles and 2 bases, base 1 and base 2. Now, what's kind of cool is that there can be an easy way to do the entire lateral area and bases, so the entire surface area, is if we open this up to a net, we will see that this side is the length and this height is the width. And if we end up doing that 1, 2, 3, and these 2 pieces left over that I cut would be 4, we would have 4 areas of rectangles, which would be the length and the width of 1, the length and the width of 2, the length and the width of 3, and the length and the width of the 4th one. Okay, why am I showing you this? Because if you notice on your base, the length and the width gives you the width of each one of these unfolded rectangles. This length here is this length here. This length here is this length here. Too short on the side and too longer in the middle. So basically, the perimeter around the base gives you these 4 lengths across the top because we're unfolding the net. 1, 2, 3, and 4. So to find the total surface area, we can use the perimeter. A plus B plus C plus D. A plus B plus C plus D. Because when we open it up, this perimeter around the base gives me 1 dimension for each one of those lateral sides. It gives me 1 dimension. This corresponds with A. This corresponds with B. This corresponds with C. And this corresponds with D. So when we open up the net, we see that if we add up all of these edges along the base and then multiply those edges times the perpendicular height, that height is the same here, the same here, the same here, the same here. So what we end up with is 1 length width, 2 length and width, 3 length and width, and 4 length and width, which gives me all the lateral area, and then the length and the width of the base gives me this piece and this piece. So we use up all 6 surfaces in order to do surface area. So surface area, which we're going to call SA, is equal to the lateral area, and in these particular shapes, the 4 sides, plus 2 base areas, which are the 2 top and bottom. We can sometimes only want to deal with the surface area, and when we deal with the surface area, we can find that these 4 lateral areas, not the surface areas, but when we want to deal with just the lateral or just the sides, we can do that by finding the perimeter, A, B, C, D, which is A, B, C, D, the perimeter times the height, because the height is exactly the same for each one of those rectangles. Sure, we could do length times width plus length times width plus length times width plus length times width plus and do 4 separate rectangles. It may be easier to add all these up to get my perimeter and multiply once. It's up to you, but we will practice a little bit. Okay? And the surface area is the 2 parts put together, and the base area is just the bases. You have to apply what you are asked for. Do they want the bases? Do they want the sides? Do they want both the bases and the sides? Okay? So, this shape and this shape are the same. This question says use a net. Using a net is easy. We all want to do length times width plus length times width plus and do the net into pieces. But I'm going to show you how to use the perimeter. Okay, so in this particular shape, this is my length and this is my width of the first one. This is my height perpendicular to the base. So let's go ahead and highlight in the base. And perpendicular to that base is my height. All right, so let's break down the formula. Let's say we are painting a shipping box and we can touch all six sides of a box, the two bases and the four sides. So we want the entire surface area. That's made up of two parts, the lateral area plus two bases. Then we said, hey, we can break this lateral area up by using perimeter times height. Plus, we're going to add the base area. And I have two bases. All right, starting with the perimeter of the base, I have 5, 6, opposite sides are congruent, so we have 5, and if this is 6, this is 6. So 6 plus 6 is 12. 12 plus 10 is 22. Times the height is the same for each rectangle, so we only have to multiply that once. Plus, we have two bases. This big B stands for the area of the base. And in this particular case, the area of the base is a rectangle, so that's simply going to be length times width, where the length is 5 and the width is 6. So the lateral area is 8 times 22, so 8 times 2 is 16. 16 carry the 1 is 17. So the lateral area, which is the perimeter of the base times the height, plus 2 of the bases, 5 times 6 is 30 times 2 is 60. The whole surface area is made up of two parts, the sides plus the bases. So 176 plus 60 is equal to area, 236 units squared. This is huge that you understand that lateral area is just the sides, and the sides is nothing more than the perimeter of the base. I want you to write that here. Perimeter of what? Perimeter of the base times the height, because that is the length and the width of all four rectangles. The perimeter is four-sided, so it's 4 lengths, and the height or the width is the same for every rectangle. Two areas at the base, length and width for one, which is the same as the second one, length and the width, plus the two bases. And there you go. Okay. If they want just the front sign of a door, you wouldn't have to use the perimeter, because we only want the first front panel. So that would be the length and the width of just the front piece. This is where you have to make common sense of the problem. If I'm only looking for the front door of a building, I wouldn't need the whole perimeter. Mrs. Williams, you told me that if it's a side, you have to use the perimeter. But I'm telling you, a front door is only on one side. So we wouldn't want to use the perimeter. We'd only want to use the area of the front door, a length and a width. So this is one of those things that's got to be adaptive. You have to be able to think through the problem, just like the penny problem yesterday. A roll of pennies has 50 pennies of them in a thickness of 1.5 or something, they said. So as you add 1.5 and 1.5 and 1.5 50 times, you ended up with the whole length of the pennies. I had quarters here because I wanted to demonstrate that to you. 1 quarter, 1 thickness. 2 quarters, 2 thickness. 3, 4, 5, it gets thicker and thicker. The base doesn't change, but the thickness gets thicker and thicker as our stack of coins got longer and longer. When you look from the top, you don't even see the thickness anymore. All you see is the base area. So the base area is like my pinks. And when I tip it this way, we end up with the length. How tall is this going to get? Okay? Now, when we're talking about a cylinder, the base is not a square, it's not a rectangle. So what would the perimeter of a cylinder be? Come on, what shape does a cylinder have? A cylinder is circular. So the distance around is not called the perimeter, it's called the circumference. So how do we find the circumference of a circle? Circumference equals 2 pi r. And yesterday we were using the area. Today we're going to use the circumference because the distance around is the entire distance and the height is perpendicular to that base. So the distance around is perpendicular to the height everywhere. So distance around, or perimeter, times height sounds kind of like a rectangle, right? So I'm going to take apart my $100 roll of toilet paper, and if you look at it, it's literally a parallelogram. Where this distance around, which is kind of like my perimeter, which is my circumference, which is equal to 2 pi r, is the length of my cylinder, and the height perpendicular to that base. This height is the same height for the entire cylinder. There's that height. And there we have our formula. Perimeter of the base times the height. And in this case, we're going to substitute in for perimeter of the base 2 pi r, which would be 2 pi r times the height. That gives me the lateral area, because we're only talking about the sides. On a toilet paper roll, there are no bases, so we only need to use part of the formula. Okay. And here we go. Here's our cylinder. There is the distance around, the perimeter, which is 2 pi r. And then this height, when we open it up, it's the perimeter times the height. It is still surface area equals perimeter of the base times the height, which gives me my lateral area, plus 2 base areas. And this time the bases are what? They're circles. So what is the base of what is the area of the base of a cylinder, which is a circle? Well, that would be 2, because I have 2 of them, pi r squared. Okay, So you're always going to start off with the generic formula. The entire surface equals the lateral area plus 2 base areas. Okay, because we have 2 bases. Then we specify, well, this is not a prism, this is a cylinder. So this is going to be lateral area is perimeter times height plus 2 base areas. The perimeter is going to be specified to be 2 pi r times the height perpendicular plus 2 bases, which is pi r squared. Again, this is a 2-dimensional. This is squared. This is squared. 2 things squared added together stay squared, 2-dimensional. Okay, what is the surface area of the cylinder? Use a net. Okay, what is the surface area of the cylinder? So surface area is both the lateral and the 2 bases. So my lateral area is going to be 2 pi r, the perimeter, circumference times the height, plus 2 bases. Those bases are circles, pi r squared. And cylinders are awesome because you only have 2 measurements. You either have a radius and a height, there is nothing more. Okay? Surface area. And this is the diameter. So we don't want 13, we want the radius. So 13 divided by 2 gives me 6.5. So we end up with 2. In this case, today, I'm just going to use 3.14 times the radius, which is 6.5, plus 2 pi 3.14, radius 6.5, but it is squared. And to make this much easier on me, I am going to use a calculator. And we have 2 times 3.14, so 2 times 3.14 times the height, 6.5, equals 40.82 plus, and we're going to do it over here, 3.14 times 2 times, I really should have done this part first. That is 6.28 times 6.5 times 6.5 is 42.25. We're multiplying these. 265.33. Adding together the sides plus the bases to get the surface area. Leave it in your calculator, add the other part. Okay, and I'm going to do it again on my calculator just to make sure that I push the buttons correctly. So we have 6.5 times 3.14 times 2, 40.82, and then doing this correctly, 6.5 times 6.5 times 3.14 times 2 equals 265.33. Add them both together, the bases plus the sides, and indeed we get 306.5 units squared. Okay, now there we go. Now we're going to apply the math. All right, what is the surface area of the cylinder? Use a net. Remember we said height can be on the inside as well as the outside. Here is my height to the base, but here is my height to the base also in the middle. Okay, so this is 60 degrees. This is a right triangle. Voila, we have special right triangles. All right, so if this is 60 degrees, This must be 30. So this is my hypotenuse. How do we get to the small side? Well, simply small equals S. Hypotenuse equals 2 times the small. If my hypotenuse is 10, then 2 times the small equals 10 divided by 2. The small equals 5. So if this is 30 degrees, this is 5. So now what did we actually get when we found 5? You got it. This is my radius. So we know the radius equals 5. And then the height would be my medium side. And the medium is nothing but the small times the square root of 3. So this is the small. This is the small times the square root of 3. The small happens to be 5 times the square root of 3. That's my height. And the rest is plugging it into the formula. What is the formula? The sides plus the 2 bases. 2 pi r, so 2 pi r. Two times pi times the radius times the height plus the 2 bases, which is 2, and the formula for the base is pi r squared. And then you simply plug it into the calculator. All right, so make it as easy as possible. Do your whole numbers first. 5 times 5 is 25, times 2 is 50, 50 times pi, 50 times 3.14 equals 157 square roots of 3 plus 5 times 5 is 25, 25 times 2 is 50, 50 pi. The surface area is 157 square roots of 3 plus 50 pi. If I wanted to leave it exactly, that would be as exact as I could get it. If I wanted to approximate it, then I would plug it into the calculator. 3 square roots times 157 equals 271.93 plus 50 times pi is 157. 157 plus 271.93 equals 428.93 units squared. All right. What I want you to take away from this is you have lateral area and you have base area. When you put them all together, you have surface area. That's it. Now, the video would be too long, but the same thing with perimeters and cones, and I'll make that a separate video. Enjoy.